Hi, you guys. Now, with the end of the school year coming quickly, I want to make sure we touch on geometry. You see this in your math tests. You'll see it a couple of times in sixth grade, but the problem is geometry is always the last in every textbook. So we barely get to touch on it. So I want to make sure that you guys have seen this, you've heard it, and you're like, okay, yeah, I'm feeling good about it, okay? So when we're looking at geometry, we're talking about shapes. Right now, we're talking about shapes. Now, we look at the root words of our shapes, but we gotta go back a little bit. Let's rewind and let's start at the beginning. All right, all of these shapes up here are a polygon. Now, a polygon is a closed shape. So take a look at this square, closed shape. Look at this triangle, closed shape. Look at this. See how that's open? Oh, that is not a polygon. Oh man. Does not work because it is an open shape. See, you can fit stuff in there. That's like a M&M candy jar or something. Polygons are closed shapes. Now, polygons have a couple of different qualifications that make it a certain type of polygon. Polygon is that big sweeping umbrella, and it's got all these different shapes underneath it. Then a couple of other words come through, and then they have more qualifications, and it kind of makes like a little tree of specifications, okay? So, first and foremost, today we're going to focus on quadrilaterals, all right? So quad is a root word, that's a prefix. Quad means four. So when I think of quad, I think of a quad runner. It's like a four-wheeler. Or quad. I just watched Princess Diaries, and the quad, they met out in the quad, and it's a grassy area in between the four walls of school, right? So quadrilateral means four. My challenge for you is to think of other words that start with quad, and let's make connections of why it's four. Bring them to the Zoom meeting. That would be very fun. Okay, so that's a challenge. Think of some other words that start with quad. All right, but when we're working with quad, there are a ton of different quadrilaterals. So remember how we've got that sweeping umbrella of a polygon, then we've got quadrilateral. Umbrella, polygon, quadrilateral. So there are a couple of different quadrilaterals that are the same, but then they become more specified and more specific, more rare, okay? So that's kind of saying like, oh, I found a precious stone. Okay, so there's a lot of precious stones. There's rubies, there's emeralds, there's diamonds, right? So that's kind of what this is. Stone is my quadrilateral, and then we've got all these different types of stone. Okay, I hope that's helpful and not extra confusing. So when we're looking at quadrilaterals, a quadrilateral has a specific four sides. It's a closed four-sided shape. All right, so when we're looking here, you're going to see this in your packets. You're going to have a couple of these. You've got a couple of options. You could cut them out and fold them and decorate them all pretty, stick them to a piece of paper. You could stick them to the back of this pink sheet of paper. If you're like, no, Miss Marshall, I don't really want to do that. Then keep the packet together and start filling out in the packet. You're going to have to flip back and forth through the pages. Good thing you can pause in this video. All right? So find your packet, take a look. We're looking at these shapes, and we're looking at quadrilaterals today. Okay? So the most non-specific quadrilateral would be a trapezoid. Okay? A trapezoid has at least one pair of parallel sides. Now, parallel, where's my other marker? Okay, parallel means they don't cross. Right here, that is not parallel. Those are congruent lines. Parallel means that they will never cross. If I kept this marker going this way and this way, and I kept this marker going this way and this way, they would never cross. Parallel, right? Train tracks are parallel. The two metal lines on a train track are parallel. They'll never cross, or the train won't work, right? So a trapezoid has two parallel lines. Now look, if I put this one here and this one here, uh-oh, they're crossing, right? So they have at least one pair of parallel sides. So if I flip this up, here's my trapezoid, right? Here's my parallel sides, one pair of parallel sides, and then look at that. Oh, no, they cross. So if I flip this up, how many sides? That's the first and foremost. 1, 2, 3, 4. 4 sides. How many are congruent? Now, congruent means the same. They mean equal. So I'm looking at this one. This one's really long. This one's really short. They are not the same length. Those are not congruent. This one and this one, they are congruent. So 2 congruent sides. They're equal, right? This is the same length as this. Next one, pairs of parallel sides. Well, there's one set of parallel sides. 1, 2, right? But that, remember, parallel, you have to have 2 lines. So that's why we're going to say one pair of parallel lines, because a pair means 2. And then how many angles? 1, 2, 3, 4. That's their corners. That's where lines meet. So 4 angles. How many right angles? Now a right angle is where it's perfectly, and you can put a little square in it. There are no right angles, no perfect 90-degree square angles. So how many right angles? 0. So really and truly, the only specification that this trapezoid needs, you need 4 sides and you need 1 pair of parallel sides. So this can also be called a trapezoid. I gotta make sure I spell it right. Okay, and I'm gonna write it right up here, a trapezoid. Okay, next, a trapezoid. After a trapezoid, we move up. All right, we're getting a little bit more specific. So we go up to become more, well, actually the square is the most specific. Yeah, all right, well, we're looking at a rhombus. Now, a rhombus, unlike a trapezoid, it's a parallelogram. So it's got both sides. Here, these lines are parallel, and these lines are parallel, right? Parallel, they don't cross. Parallel, they don't cross. And all of the sides are equal, right? They all are congruent. Remember, congruent, you could put equal right underneath it. Congruent means equal. Ooh. Let me zoom in a little bit for you guys, okay? But you've got your pink sheet in front of you too. Here, I'll zoom in. You can see where I put the equal sign. Ooh. Oh, guys, sorry. Right there. Congruent sides. Sorry, I am not great with this camera. All right. So, we're looking at this. This side is equal to this side. That side's equal to that side. Okay. So, I got 4 congruent sides, 4 equal sides, and my top and bottom are parallel, and my 2 sides are parallel. So I'm going to flip this up. First, nice, easy question. How many sides? 1, 2, 3, 4. 4 sides. How many congruent? How many equal sides? 4. Right? This one's the same length as this one, same length as this one, same length. Okay, 4 equal sides, 4 congruent sides. All right, now, how many pairs, remember pairs mean 2, how many pairs of parallel sides? Let me bring back out my markers. Those 2 are parallel, check. Those 2 are parallel. Okay, so I've got 2 sets of parallel sides, 2 pairs of parallel sides. How many angles are there? 1, 2, 3, 4. However many sides, there are going to be that many angles, because it's a closed shape. So 4 angles. How many right angles? Nope, 0. 0 right angles. Now, let me show you real quick. If you are going, okay, Miss Westman, you keep bringing up right angle, and I'm not sure what that is. A right angle is a perfect edge. It is 90 degrees. It makes a perfect corner, right? Now, this right here, not a 90-degree angle. It has to form a perfect side, and it could make a square. It could make a rectangle. See that angle? That's a perfect right angle, right? Okay. So we have taken care, oh, I'm sorry. What could this be called? It's a rhombus. It's a parallelogram with 4 congruent sides. RHOMBUS. All right. Are you filling this in your packet? Have you cut them out? It's up to you, right? Okay. Our next one, remember, hit pause if you need to. Our next one we're looking at is a square. It's like I took this rhombus and I squared it up. I pulled these edges over and I made it a perfect square. Now look at that 90-degree angle, right? Oh, that one's kind of folded. Let me pull a different one off here. Look at that beautiful 90-degree angle. Ooh, look at that corner, right? It matches. I can put a piece of paper's corner right into that and I could say, ooh, that's a 90-degree angle. Because look up here. If I put this underneath, right here, it should be, right? See how that is not a 90-degree angle? If it went straight up like that, it would be, okay? Gotta get that off. Okay, so now we're looking at a square. Now, with a square, there are a lot of requirements, right? With the square, it needs 4 parallel sides. I'm sorry, not 4, 2 pairs of parallel sides. There's a pair. There's a pair, right? They will never cross. 2 pairs of parallel sides. Then, all of the sides need to be equal. All of them need to be the same length. And it has 4 right angles, right? That make that perfect corner. So, let's look in here. How many sides? 4. How many congruent sides? How many equal sides? Remember, congruent means equal. How many congruent sides? 4. How many pairs of parallel sides? 1, 2. Because remember, pairs count as 2. So I've got 2 pairs of parallel sides. How many angles? 1, 2, 3, 4. 4 angles. And how many right angles? 1, 2, 3, 4. 4 pairs of right angles. This can also be called a square. All right. Now, a rectangle is where I take a square and I stretch it out just a little bit. It still has those perfect corners, those right angles. See them? See how I can put that piece of paper right in front of them? And it lines them up. So if I'm looking at that, okay. All right, now let me check about the parallel pairs. Oh yeah, those are parallel. Those are parallel, yeah. So, a parallelogram, right? 1, 2. A parallelogram has 2 sides that are parallel here, 2 sides that are parallel here. So a rhombus is a parallelogram, square is a parallelogram, and we're going to come back and go through. I'm sorry, I should have talked about what a parallelogram is instead of starting at the bottom. Okay, don't worry. All right, so we're looking at it. It has how many sides? 4. How many congruent sides? Well, these 2 are equal and these 2 are equal, right? So it does have, so what it would be is 2, no, it'd be, because I don't want it to be the same as this, 4 congruent sides. Okay, no, it would be 2 congruent sides. These are congruent, these are congruent, right? Now, pairs of parallel lines. There are 2 pairs of parallel lines. Right here and right here. Now the angles, how many angles? 1, 2, 3, 4. And how many right angles? 1, 2, 3, 4. Can also be called a rectangle. Okay? Now, back to the beginning. Parallelogram, which this square is a parallelogram, this rectangle is a parallelogram, this rhombus is a parallelogram. If I ask you, what's a parallelogram? What do you notice that all 3 of those have? The top, the opposite sides, right? This one and this one, those are parallel, and this one and this one are parallel. So a parallelogram have the opposite sides that are parallel and congruent, which means equal, right? So on your pink sheet, you're writing equal. So let's look. How many sides are there? 1, 2, 3, 4. 4 sides. How many congruent sides? How many sides are equal? These 2 are equal, so that's 1. and these two are equal. That's 2, okay? That's the difference between a square and that. And that's the difference between a rhombus and a parallelogram, right? These are parallelograms, they're just more specific, right? Those are the diamonds and the rubies and not just a gem, right? Okay, pairs of parallel sides. 1, 2. 2 pairs of parallel sides. Angles, how many angles are there? 1, 2, 3, 4. 4. How many right angles? No. 0. This can also be called a parallelogram. Okay, so when you come to today's Zoom, I'm going to make an image of the umbrella so that we can look at it and talk through it and practice with it, okay? So that was all that you needed to do today, is follow along and fill these out with me. And at Zoom, we're going to dig a little deeper and go through, and I'm going to show you some shapes, and we're going to see if we can name the properties and if we can name the shapes, right? Okay, so thank you guys. I'll see you later.